Welcome everyone. Welcome to the Enterprise Artificial Intelligence fifth session. The topic we are going to discuss today is a product recommendation based on machine learning. We have friends Harish Bokre, Hema, Kishore, Leela, Narayana, Raja, Sairam. They are here in this session, and few people are joining late. They sent me a message. So the recording is on so that whoever misses, they can able to catch up. But quickly, we have time, so quickly connect. Harish, welcome. How are you? You want to greet our friends?
Hi, Srini. Good morning. Hello, everyone.
Excellent. Welcome. Sairam, welcome. I want to greet our friends.
Yeah. Hello, everyone. Hope you guys are doing well.
Awesome. Hema, how's the week? And you want to greet our friends?
Hello, everyone. Yeah, I'm good. Thank you.
Excellent. So Leela from not Minneapolis. What is that? City you are in, Leela? Welcome. You want to greet our friends?
Hi all. Hi Srini. I'm from Minneapolis.
Okay, wonderful. So we have Narayana from Hyderabad. Narayana, how are you? You want to greet our friends? You are on mute. Okay. We have Raja Shiva. Raja Shiva, welcome. How are you guys doing today? And you want to greet our friends?
Hi Srini, I'm doing well. Hello everyone.
Hey Shiva, what's up?
Hi Srini, good morning. I'm doing good. Hello everyone.
Welcome. Narayana?
Hi Srini.
We can't hear you. You might have to adjust your phone.
Okay.
Okay.
Now, can you hear me?
Yeah. Okay, excellent. So let me just put everyone on mute just to make sure you don't hear any background. Okay, I'll take few questions on how you are doing on your setup, the current environment. Right now, we are still working on the Databricks. We'll be soon getting into general virtual box. I'll take up some questions. Hema asked me the slides, which I didn't share. I'll share it today. And the code and few files also I'll post it to Facebook. Right now, those links are available on YouTube, but that's fine. Okay, I'll take a few questions after some time, but let me initiate this new model, new foundation. You'll understand the relation between this model and the previous model. You'll understand the process. So, machine learning and product recommendations. It's a very, very important, interesting topic. Every company is doing. Amazon, Flipkart, they want to recommend the products. Your Xfinity, Netflix wants to recommend some movies suitable to you. A lot of companies are building even products, well, not products, companies. The new companies are forming even based on this concept. And this idea can be used to recommend anything. You may build an intelligent system to recommend trainings for your employees. You may build a company which recommends career counseling for people. Some companies are building services to recommend healthy advice based on the questions you answer, based on the intelligence they already have from the other users' data. It is a very intuitive application, and it increases a lot of value for the company. Please see. Sairam, can you read this? Or can you? This is from Netflix. They comment on one of the seminars.
Over 80% of what members watch comes from our recommendations. Recommendations are driven by machine learning algorithms.
That's correct. Even Amazon has acknowledged they almost do more than $1 billion business just based on the products people purchase because of the recommendations. Many times these products are not known to the users. When you go to YouTube, YouTube recommends. Go to LinkedIn, LinkedIn recommends the connections. Go to Facebook, Facebook recommends friends. So since the system is so huge, the products are so many, the movies list are so many, the music lists are so much. You may not be able to search relevant. You can do some keywords if you know. But what if you don't know? So this is where the system identifies your behavior. It learns from your interaction, from your interests. It also identifies people who have similar interests like you. What they do, it identifies. And do a guess, probably Sairam also might be interested in. Suppose you see Hema and Leela started talking. Say, Hema starts watching some movies. Hema, what type of movies you watch? You don't have time to watch.
That's true.
What is that? Kids movies?
That's true. I don't have time nowadays.
I know. That's how you lose interest in your own thing. But anyway, just put some Hindi movies. So what type of movies, at least though you don't watch, what type of movies you like, Hema?
Some like social message movies.
Social message. Okay. Say, hey, you are watching, you watch some social message movies. Assume now Leela also watching similar movies like what you are watching. Then now, see, Hema watched few other movies. Sairam, is it common sense that we can recommend those movies to Leela? Leela didn't watch those movies. Leela and Hema watched some common movies.
Yeah.
But now Hema watched some new movies Leela didn't watch. So, Sairam, is it fair or is it common sense to recommend what Hema watched to Leela?
Yeah, absolutely. She might like it as well.
Exactly. So this is a simple common sense aspect they use. So that is what the recommendation is all about. So, okay, Leela may not like fully, but that's okay, right? Leela won't complain. "Hey, why you recommend this?" Leela won't complain. If Leela sees this, she won't complain. So, Sairam, a question to you again. Now, say these are movies recommended to Leela based on common interests of Hema. Hema watched them. So you build a system. That system, they thought, hey, this is better. Let's recommend. So now, what action options we have? Now Leela may watch this in this week or next week, or she may not watch it. Is that correct? She do one of these, right?
Yeah.
Now, say out of them, so we recommend 6 to 12 recommendations. Out of them, suppose Leela watches 6. Okay. Now, don't you think again that gives? Oh, we recommended 12, but Leela watched 6. So, don't you think that gives you some information? Again, you are recommending. Okay, out of that, those many Leela has watched.
Yeah.
Now again, see, now Leela, and you see the pattern between Leela and Hema. Now Leela watched some other movies, which Hema didn't watch. So you can recommend those to, you feel like recommending those to Hema, right?
Absolutely, yeah.
Exactly. Whether they see it or not, it depends on the time. As Hema said, she's busy with work, kid and husband and India calls. That's all okay. Those things will be taken factor over a period of time. So that is that is called collaborative filtering. This concept is called collaborative filtering. So you are collaborating between Hema and Leela. But again, it's not just Hema and Leela. We have Harish, we have Narayana, we have many millions of users in the internet. So they continuously doing it. In the process, systems will be learning it. So it's such a simple concept. But behind the scene, as the data is growing, as the data is growing, you cannot simply compare people. It uses, to compare that, it has to use a structured mathematics. So behind the scene, it uses simple but powerful mathematics to come to some conclusion, come to some logical conclusion. I'll talk about that. We don't need to know deep math into it, but at least I'll throw some idea, because all those mathematical logic is coded in those libraries. You'll be using them. So these are simple common sense ideas. Uses powerful mathematics, but simple and powerful mathematics. It uses data. Continuously data will be growing. And these systems use powerful computational power. In the process, using a machine learning process, you start building the intelligent system. And these intelligent system is a machine learning system. You start learning. Over a period of time, it improves. The continuous learning. That is a big picture. I'll go to details, but everyone got the idea. So a machine learning system in general, not only the movie recommendations or music recommendations, product recommendations. The machine learning system is a learning system to become expert. So when you build it, it won't become, it is not overnight, it is an expert. It is a learning. Hema, do you agree with me? If something is better than nothing, earlier you are not recommending anything. So do you agree with me? Some intelligence is better than no intelligence?
Yes, sir.
Definitely. Somewhere you have to start, right, to improve the system. start improving. Then, and it's going to continuously learn. So to summarize, any machine learning system uses simple concepts, simple math, but simple and powerful math. It uses continuous data, historical data and ongoing data, huge data, growing up data. It uses the power of cluster computing, huge computing, which is not available few years back. And it uses a process, a machine learning process, and build a learning system that is going to learn continuously and over a period of time. It becomes an expert system, but it solves a very big problems of the company. So these systems are so powerful. With these systems, some companies can compete with even giants. There is a company called Spotify. Harish, do you know this company, Spotify? S-P-O-T-A. Yes.
Yeah, Shani,
What is that?
it's a music streaming service similar to Apple Pay or like Google Music, where it does not actually own anything, but it provides a service, music service, on all the mobile devices or on computers.
Correct. So it competes with Apple Music. Spotify is a startup, but do you know it is dominated when Apple unable to compete with it. So,
Yeah,
so it is not they have a powerful machine learning system, which they started quite early than Apple. So they were in advance. They started learning. Their recommendations are very fine because they have good data. So automatically people have a great experience. So that's where people are ready to pay for it. And it is a multi-billion-dollar business competing with giants. Everyone, Sairam, do you appreciate the whole concept? How these intelligent systems, simple ideas, simple but powerful math with data, with computation, with machine learning process, building a learning systems to build a powerful problem.
That's the current way of life. Yes, absolutely.
Okay. Emma, do you get the sense? Sometimes it may sound, the system building may sound easier than even the web services you are building after knowing it. But do you see the value of the company or the problem you are solving? Emma, do you see that?
Yes, Srini.
I want you to understand this very much. Kishore, do you see that? Shiva, Narayana.
Yes, Srini.
Yes, Srini.
Absolutely, Srini.
Yep.
Yes, Srini.
Okay. Now we have DK and Hari also joined.
Yes, sorry, I'm a little bit late today, Srini. I just joined 10 minutes back.
No problem. DK and Hari, just for a quick recap, a 1 minute recap, we are doing a recommendation system. So with examples, music recommendations or product recommendations, or movie recommendations.
Okay.
This is used based on the concept of collaborative filtering. It means you like something. Sairam also likes similar things. So then say a DK purchases one car. Probably Sairam also might like that car. So that is called collaborative filtering concept.
Okay.
So these concepts are supported by mathematics in the back end. when you have a huge data. So these recommendation systems are very intuitive and very powerful. Netflix users, Amazon users, LinkedIn recommends friends, Facebook recommends friends. Even there are some companies, just new companies are forming just to recommend things. Spotify is a music streaming company, which we are discussing. The recommendation engines are very fine compared to Apple and Google, because they started in advance at early stage. Even though it's a startup, it's a multi-billion-dollar music industry, streaming industry company competing with Apple and others. So you may be working in a company, whole company is fully doing this recommendation. Maybe one whole project may be this one. Or you may do a startup working with some people to build some recommendation engine. It can be even used for personalized medicine based on people's diagnosis, based on their DNA. Your system may recommend personal medicine. These concepts are used even psychological counseling. People can fill some questionnaires and they can get advice. So the applications are limitless, very powerful. We just discussed behind the scene. It uses simple concepts, simple but powerful mathematics, which are coded in the library. You don't have to break your brain because you are doing applied machine learning. You just continuously data. It learns from the data, the system you are going to build. It uses powerful computation to handle big data. And the data is growing. And you use a regular machine learning process to continuously improve the models. And you'll be part of a team where recommendation and personalization is the core theme. This is also very much used in marketing, data-driven marketing. So when you're going to try for the job, this particular application is going to play very, very helpful for you to interact with the recruiting companies to project your skill in the machine learning. DK, does it make sense? I'm going to move forward.
Yeah.
Sure, absolutely.
Okay, excellent. Please look here. I'll come back to this. Let me throw some ideas now. Let me put some foundation. I have code I will show you. Probably we may not be able to finish everything today. I'll be taking up to 9 o'clock, then there will be a break. Arun will be taking some answers. We'll continue tomorrow and next week. But let's focus. I'm going to put a very good foundation for you. Okay. Sometimes even just take this problem and put in your resume because supporting use cases. Go deep into it after we finish the class and after a few weeks. Probably you can try for the job. It's learning Scala and Spark, handling big data easily. Just use this algorithm. You can apply for some companies where you can say, I can build recommendation engine. You can able to get into the machine learning. Okay, let's see guys, everyone. Sairam, DK, Hari, everyone, Hema, Leela. So look here. In any recommendations, you'll have users, thousands or millions of users. These are 1, 2, 3, 4, 5 like this. I'm putting in this. Then you will have items. I'm walking right side, showing a 2-dimension. Sarah? Item 1, item 2, item 3, item 4, item 5, item 6. So million items, maybe million users, 10 million users, 10 million items, or any combination. M into N. M users, N items. Okay. So what does this mean? Sairam, if this is blue, it means this user, say 1, 2, 3, 4, 5, 6, sixth user like this product or given a rating. Rating 2, rating 3, rating 4, rating 5, rating 6, whatever the maximum rating. Given the rating. What does it mean? This user for this product given the rating. This user for this product given the rating. So these are users. These are items. These could be music items, movie items, products, anything. So user, product or items, users, items, rating. These 3 words you need to remember in this recommendation engine. Users, items, and rating. So users give rating to, may give rating, may not give rating. You see here, this user only given rating for only one movie. Sometimes the companies collect implicit ratings. Suppose DK has seen a movie 2 times. DK, have you seen any movie 2 times? Can you tell me that? Probably I will see.
Sorry, Srini.
Have you seen any movie 2 times or more than 1 time?
Yeah, I've seen 2 times. Bahubali.
Oh, Bahubali. Okay, say here. So he might not have rated the movie when he watched on Netflix or a system, Xfinity. Assume, of course, he has seen on the outside, but assume one product he purchased repeatedly, or he commented on this product, given a rating. So sometimes even, they do a guess. You purchase second time a product. So you might not have given explicit rating. So they might do implicit rating for system building. Maybe 2 or 3 or 4. Somewhere they will start. This is all just to gradually building intelligence, gradually building learning. So now don't go into details how they collect the ratings, etc. You all know people give ratings and some people don't give ratings. But the fact remains that there exist users, there exist products, there exist some ratings. This user has given only so many, say 1,000 products are there. Only for one product, they are given rating. Some user may not give anything. See this user, Sairam, this user hasn't given any rating. That is all okay, which is a fact. So imagine this is a matrix. A M by N matrix. So don't worry if you don't recall matrices. It's a simple grid, Excel grid. So you have users, M users, N product. So out of them, some users are given the rating. So all users don't give all ratings. So that's why this matrix is called a sparse matrix. Sparse means not dense, so isolated. A lot of empty spaces will be there. That's why it's a sparse matrix. So it's called user product rating matrix, or simply say ratings matrix, because always users will be there, products will be there. Okay, does it make sense? I'm just putting some foundation. Sairam, question to you. Will all the users rate all the products? Yes or no?
No.
No, right. So Then what is the recommendation? What is the recommendation? Please look here. The idea of the recommendation is, hey, this user likes this. These users like this. Now this user like this product. Probably this user also might like this product. So it means, so for this user, you can recommend this product. You can recommend this product. Probably the same rating. Sometimes it may be rating, sometimes it is just, hey, let's recommend this. But internally they put some rating. Suppose hey, you recommended, Sairam, you recommended this product to this guy because these two users have common interest. You assumed it. You recommended. This user seen that movie. Has seen that movie. So that is a reinforcement to you. That tells, okay. So we recommended this guy seen that. Oh, it's a good sign. Okay. So that type of concept with so much data, we'll have to do it. That is the recommendation problem. So how does it do it? Behind the scene, it is a mathematical problem. The problem is this. This is a matrix. So this matrix is not a dense matrix. So our idea is to find some approximate values for all these empty cells. All these empty. When I say approximate numbers, yes, as I told you, this is ratings. The ratings could be like this, the numbers. 4, 5, sometimes less, some ratings. So imagine like this. These are the users, these are the movies, these are the ratings. So what is the rating for this? 3 or 2 or 5? Why you need those ratings? Because based on the ratings, you can recommend. Because you won't recommend 100 movies at a time, right? Maybe you want to, Sairam, you want to recommend top 5 movies. So top 5 ratings movies, top 3 or top 10. So without confusing you, the problem we are going to solve is this. The users and items, there will be some ratings given by some users. Lot of cells don't have ratings. So we need to find out the ratings for all the missing cells. That is the idea. So once you fill all the ratings, DK, please look here. Now say for this one, this user don't have anything, right?
Yeah.
But somehow imagine we filled all these gaps. It means we have some approximate information that this user, how, rather you can say for this user we can recommend, right? All this, we have numbers assumed. These are empty. Somehow we filled this with the numbers, rating numbers. Say, want to say some 20. Out of those 20, let's recommend top 5. Out of this 20, if this 20 has some numbers, weightage, rating weightage, we can recommend them top 5, right? If you know the numbers.
Yeah.
Is that fair statement?
Yeah.
Okay. So that is the problem of the recommendation. How it does that, you are going to see. Hari, any question on this?
No, Srini, I'm just understanding the concept here.
That is fair. That is fair. Now let's go. So anyway, any company you go, you will have a user, item, and rating. So I have a file which I'll give it to you. I have a user ID, item ID,
Okay.
and ratings. Sparse ratings. I mean only some ratings. Okay. So the process remains the same. Sairam? So you need to get the data, you need to clean and prepare that suits to that model. I'll do the train data and test data. Then I'll build the model. I'll apply that on the test data to see how it is doing. Then we'll think of the improvements. So let us start with some data. Just do some analysis, some preparation. Different models take different types of inputs. When I say input, last time we took the dense vector as the points. Here the inputs will be a rating object. How to build those rating objects? The k-means cluster, Emma, you remember we built a dense vector.
Right, Srini.
So we use that, what is that, dense dot vector, vector dot dense.
Yeah.
So here the input is rating object. So there is a built-in rating object. So rating has a certain inputs. I'll show you. So get the sense of it slowly so that you'll understand. Okay, so let me share my whole desktop. Okay, good. Harish, can you see this? Databricks.
Yes, Srini, we are
Yeah, Srini, we can see it.
Okay. So let me see who all here. We have DK, Hari, any new people join? Okay. Surya, welcome. Nagesh, welcome.
Thanks.
So Nagesh, we are building a recommendation model where we are going to build a recommendation model based on the data we have. So
yeah,
I'll talk more. Okay. So everyone, DK, Hari, everyone, we will be needing some libraries. Last time we used k-means libraries. This time we'll be using recommendation libraries. So these are standard templates. So for a period of time, you'll repeat it. So it uses HEMA, Spark MLlib recommendation package. That ALS. ALS means alternative least square. Alternative least square. It uses a mathematical technique called alternative least square that is coded in those slides. It uses matrix factorization model. The model we are going to build is a matrix factorization model. As I told you, when you are applying this whole logic of collaborative filtering, that DK likes this car, and DK and Sairam has a common interest, and probably Sairam might like this. So all these ideas, when you put into mathematics, it comes into a matrix factorization. It's not too complicated. It's all coded in the libraries, but when we apply, it's not complicated. It's very simple. I'm going to introduce to you. So this is a matrix factorization model. Last time we built a k-means model. We took the k-means object. Can I remember? Based on k-means object, we create the k-means model.
Great.
So this time we are going to take a ALS object with ALS object, we will be building a matrix factorization model. How you do it, I'll explain to you. Then this is the rating object. If you recall from the last classes, you have a vectors object, dense vectors objects. So we'll be using rating object. What is that rating object? I will introduce to you. So I'm running this. So I'm good. So interestingly, this workbook, it gives you heading also. You can sign up. When you are sharing to some people, you can use this. See, it has the title. You can write it here. You can write it. Okay. So that it will be easy for others. Okay. Somehow you are following me? I'm taking a data. I'll give it to you. I'll upload to you. The simple u.data. It is a text file. So I'm writing into raw data using Spark context, a text file. I know its structure. I'll see what it contains. I loaded it into this one. It contains user. It contains product. It contains rating. It also contains date timestamp, unique date timestamp, which I'll not be using it. I ran it, and I printed 5 rows. Sorry, I took 5 printed. Param. See, this is the user column. This is user ID. User ID. We don't know who those are, but you have a user ID just like employee ID. They may have other files where whether that user is a GK, whether user is a SIROM, that can be there. That we can link it. Now that is not a big deal. Think that is a separate file. This is user ID. This is product ID HEMA. This is product ID. What is the description of that product? This product can be a movie name, this product name or music name, etc. This is the rating for this user, for this product. This is the rating he has given. For this user, for this product, this rating they have given. These are actuals. So this user might have given rating only for one product. So this is the format. So your file is nothing but.
What is that number? That rating number? What does it indicate?
Like a rating. Say suppose 5,
1 to 5.
Okay. Yeah. So you how much you liked it, Hari?
You go 3 stars, 4 stars like that.
How much? 4 star.
Okay. Yeah. Okay.
So they put it 1 to 5 or 1 to 10, whatever, some rating. Sometimes it may not be explicit. You have seen the movie. That's why I'm not going to those details. When you join a company or when you think more, you can figure it out. So sometimes people don't rate, but at least everyone has seen it. Now Bahubali is hit. So these guys seen Bahubali. Probably for 80%, let's put 4 out of 5. For 20%, maybe some critics like Sati Mahesh, they put 1 or 2. For 10%. It's one guessing.
The reason why I was wanting to know is for that example, we have to know whether 4 is better or 1 is better than taking a rating out of 5.
That's good. That's good. Now you know, right? 1 is bad, but that's good. Good question. Let's move.
Yeah.
So this is some unique timestamp. Don't worry about it. Date, time. I don't know what format, how it makes. It's basically date, time, and seconds, everything. But anyway, it's time. Later you Google it, understand Unix timestamp format. So that's not very relevant for us. So these 3 are relevant for us. So when I run this SIROM, it's nothing but a RDD of string, right? Yes or no? Sarah, the RDD of string.
Yes.
So out of them, I just want these 3 columns. So I need to split this. I need to split. Is it comma separated or pipe
No,
separated?
I think it's I think it's a tab.
Yeah, it's a tab separated DK. When you want to do a tab separated, just like earlier. Earlier you split with comma. Now you split with tab /t. So I took this file, this RDD, raw data, map each line dot split with the tab, with tab. Then when you split it, it becomes an array. So you can take 3. So let me do it. First, let me comment this. But just don't do it. DK, please see. 1, 2, 3, 4. You just split it. That's it as an array. It's an RDD of array of array. Sorry, RDD of array of string. If I take 3, this 4th element will be omitted. Please check. Saram, do you see that? If I take 2, I'll have only still array of string RDD. It's still array RDD because it's just a transformation. It's the array of 2 numbers. If I just take 1, so only 1 element. So I want first 3. Hari, do you agree with me?
Yeah.
You see this? This is user ID, product ID, ready.
Okay. Shini, I have a question. This is Harish.
Yeah.
So
Yeah.
val is immutable, right? So you are you are able to change it, like take off 3, take off 2. So and it's allowing. And it's immutable. How come it's allowing?
Hema, what is your answer?
Harish, we are not changing the value of raw ratings RDD. We are just displaying part of it.
Okay.
That's
Got it.
a good question. So Hema is right. Raw ratings we didn't change. The take is an action. The output is stored in a default variable.
Okay. Yeah.
That's good. We just split. Now, Sairam, you remember when you split last time, whatever we split, we want it as a dense point. So vector dot dense, we pass to vector dash dense. Vector dot dense. So in recommendation, it doesn't use it as a point. There is an object called rating object. A rating object. Let me see. This is the rating object. A rating class. So you'll create rating object. Emma, a rating object takes user ID as an integer. Any product as an integer. Take rating as a double. Okay.
Okay, Srini.
So I'm going to pass. See here. I'm going to take each line of this array. Okay. Each line of this array, which belongs to ratings RDD, raw ratings RDD. This is the raw ratings RDD. Map. This is an array. I'm passing it to, instead of passing it to vector.dense, I'm passing to rating object. So that rating object is used in our algorithm. That's why we are doing. That's how they design the package. That's how they design the algorithm. So your rating object takes user as integer. Of course, earlier it is a string. It is a string. So converting. So line 0 means this is an array. So 0 means the first item. This is second item. This is the third item. So first one you'll be converting to integer. Second one you'll be converting to integer. Third one you'll be converting it to double. So it's a rating. 5 means 5.0. Product ID remains as an integer. The user ID remains as an integer. So when I pass it, DK, question to you. When I pass it, this is the output of each item, right? Each. This is an array. So it's an RDD of an array. So now the output ratings RDD. Tell me, is it an RDD? It's going to be RDD, right? And is that RDD is an RDD of string or RDD of array or RDD of what? RDD of rating object, right?
Yeah.
Let me run.
Okay.
You remember last time you got an RDD of dense vector?
Mm-hmm.
Look here. Ratings RDD is output, correct?
Yeah.
It is an RDD. RDD of what? RDD of this object, right?
Yeah. Yeah. RDD of rating object.
Correct, exactly. So earlier it is RDD of an array. Now that the array, this is array line, this is converted to rating object. So it is still an RDD. RDD of a rating object belongs to this package recommendation of MLlib, Spark, Apache, Watch. So I want everyone to see that, observe that, how it is changing. That would help you to gain more insight. Okay, what is happening in your code? These are simple coding, but they have a deep meaning. Emma, do you agree with me? See, with one line, how much it does? It goes to every row. Imagine you have a 10 million rows on the cluster parallelly.
Ratings RDD and converting it to a rating model and storing it back in a RDD.
Correct. Harish, do you get this point, Harish?
Yeah,
sure. Rating object came, ratings RDD. Okay. Now this is ratings RDD, but this is an RDD of rating object. Rating object. So let me print that. See here, I have ratings RDD. I'm taking 5. It's nothing but simple. Each one we are printing. It's a rating object. Rating. And these are the values.
So, Srini, so this rating object is directly associated to this model. Am I right?
This package. Model we are going to, you can think it as input. Rating is not a model. Rating object means a simple rating object means it has
I was trying to associate it to the recommendation. So how do I associate that? The rating to recommendation.
It's input, Hari. Then we'll use this input into a model to train.
Okay.
Till now we didn't talk about model. We are just talking about input only. Last time you remember we created the dense vector.
Yeah.
So is dense vector is a model? No, right?
No. Okay.
Dense vector is an input.
Correct.
It's a point. For this, the input is a rating object. So the rating object contains nothing but user ID, product ID, rating. That's it. Instead of putting as an array, they're calling it as a rating object. So that that object may have additional properties, additional functionality. That should be okay, right? Hema, agree with me? Any comment, Hema? You want to do? You're on mute. Okay. Okay. I'm just doing the rating count. How many are there? Harish?
It's 100K.
100K. Let's see how many our raw data contains, because raw data. How many do you think?
The host 50. Sorry, okay. Yeah, 100K.
It is the same. See here, 100K. Every row is split. Every row that is split is converted to rating. There is no filters. It's just a map. You have 100K rows, 100K strings. The 100K strings are split. 100K rows that are split are passed to ratings. So 100K rating objects. DK, that makes sense, right?
Yeah, so 100K rating object means totally you have ratings of different products by different users, and the total number is 100K.
Yes.
Correct. No?
It means this one, right?
Yeah. So totally of this, the whole rating, there is 100K, which is like the users and the products taken as a whole.
Correct. See, this user, 1. So it's
Yeah.
one rating object.
Yeah.
Whereas this user has 1, 2, 3
Three
rating
yeah.
objects.
Correct.
This user has 3. This user has 1. Like that, right?
Understood. Yeah. Correct.
You're right. That's good. Saram, am I confusing?
No, so the users could be less than 100K, right?
Could be.
You're right.
Because
You're right.
if some of the users have multiple ratings and multiple products,
Yeah.
the total number of users could be less than 100K. At the same time, not all the users have given the ratings.
You're right. You're right. Let's see that. That's a good question. Let's see that. See here, first I counted 100K. Saram has brought up a very good question. DK and everyone, you want to know how many users are there actually. The users can't be 100K because, as rightly said, here one user has 1, but this user has more. So the 100K, the user need not be 100K. Let's see. We can find out. So let me. This is the total rating. Okay. Now I'm going to find how many products are there, first of all. How many products? When I say how many products, there are 100,000 ratings. If you see this user, Harish, did a rating of this product. This user also did the rating for this product. So this is 1 and 2 ratings. But these 2 ratings belongs to how many products? 1 product or 2 products?
The same product.
The same 1 product. So though these are 2 rating objects, they are only one product. So the distinct of this product is only one.
Yeah.
Let's go. So what I'm going to do is now I'm going to take this rating object. In that rating object, I'm going to take these products out. There may be some duplication because this user might have done the same, right? Just I've shown you, right? So I'll find the distinct of this. I'll get the number of products. I'll get the distinct of this particular column. So then I get the distinct user, because one user, this user, where is this guy? This user, from user perspective, Harish, this same user has a 3 rating object. Does it mean there are 3 users? No, right?
No, it's the same
Only
user.
one user.
Yeah.
The distinct. So I'm going to find those distinct. I'll use simple Scala syntax. There is another option is we can convert this whole file into a table. Then even you can use your select equal distance that we can see later. Right now, I'll use a simple concept. Where what I'm going to do is I'm going to take each rating object. This is a rating object. From the rating object, Emma, this is user, this is product, this is rating. Is that correct, Emma?
Yes, sir.
So this is the signature of rating object.
Rating construct.
This rating object has a user as integer, product as integer, rating as the double. Earlier, I've shown you as item. This as I shown it as a variable only. But the real signature is these are the attributes. The user. If I say, hey, rating dot user, I'll get this. Rating dot product, I get this. Rating capital rating. Rating dot rating, I'll get the third. Let's use it. Total number of movies rated. This is a string. I'm concatenating it to ratings RDD. I'm going to take each product out. How I'm doing this, DK? I think now you started understanding this Scala syntax. I'm going to take each rating. From that rating object, I'm going to take the product out. Product out. So I get many products. Many products. Out of these products, I'll take the distinct. Take the distinct. Then I'll count them. Okay, let's see. Total number of movies or products or items rated. This is a string. I'm adding it to this line. This is where it's complete. It took the ratings RDD. It mapped each rating to only that rating that product, which is just a number, integer. Distinct of those list, I counted. So I got 1682 products.
So is the product is a reserved word or is it something we defined earlier?
The product is on that rating.
Rating
That's a good
Oh,
question.
okay. Rating.
is a class from ML, and it has.
Emma, you want to?
Yeah.
You want to give that signature from the API?
Yeah,
It will help you to see the API. Huh?
Yeah, I can share it. People can check here in this link. Apache.org API. I gave the link in the chat stream.
Awesome.
Oh, so it's a user, product, and rating. Okay.
It's a constructor. So we'll see after some time. DK, well, go to the API is like a big dictionary, but let's get hold of it. Let's not digress right now. DK, that makes sense, right? You came from C++ background, building constructors.
Sure, constructors, yeah.
So it's a basic rating object. They built it in the package. Its signature is right. User is this one. Product this one. Okay. Keep moving. Hurry. Don't get confused. Saira, that's a good question. So I got the products. Similarly, let me use it for user. Distinct user. Harish. Print a total number of users who rated the movies. Is that rating object, each rating object, mapping it to user, and distinct of those users, and count of those users. Okay, so 943 users, 16,682 products.
Yeah. 100K.
Hari? Now you got 100K. 100K is total.
100K ratings are given by 943 users for 1682.
So this is 943. This is 1,682. Hari? It makes sense right now, right? For your question. These are 1,682. You're on mute, Hari. These are 942. So this user may have more ratings. This has only one rating. This has this one. Orally, you got 100K. DK, any comment on this? Can you summarize it a little bit in your own words, DK, so that you're all in the same page?
Yeah, basically, you got the total number of ratings, which is 100,000. And you got distinct number of users and distinct number of products, right? So that's what you got. But they may not be total number of users. They are only distinct number of users that I have given rating.
Yes.
Right? The 943 is not the total number of users. These are distinct. 943 are the users who has given rating.
Absolutely. In this matrix, we have all users. So see, assume some rating is not there. Of course, that
so we didn't count that user.
You're right.
We didn't count
that user.
Yes.
We didn't count that user. But if our data, if data is there, that user, that user data as a user ID, it's not there actually. It's not there. You're right. It's not there. Yeah. So assume here at least one are there. Put that as an exception. A guy who is not at all here. That user ID is not there at all. You're right. So usually what happens is they do some approximation. Suppose Hari watch movies. Hari, you watch movies, right?
Yep.
So what is this going on? What is that? Oru Kadal, what is that recently made a lot of thing in Malayalam? Is it released?
You're asking about that Wink lady, Wink girl?
Yeah. I think that's
I don't know.
Priya Warrior.
Yeah.
Yeah.
Is it released?
Yeah, the movie is out, I think, yeah.
Okay, we will talk about later. Okay, I'll call you again. Okay. Okay. So You are right. See, usually DK, they might give some implicit. Somebody doesn't rate. Suppose they might have seen the movie. They give some default rating, some 2 or something. So in a way, assume, even though this picture didn't capture, assume all users are there. They have at least 1 rate. Is a fair statement, DK?
Sure.
You're on mute.
Yeah.
Okay. So at least we have in the file, we have users. These many users are there. These many products are there. These many ratings are there. Is that a fair statement? Sarah? These many users we have. These many products we have. These many ratings we have. Combination of it.
Yeah.
Okay, very good. Let's go. This anyway we got. So we are still doing this process only. What is that? This you want to use this. You're getting the data, just cleaning it up, preparing it up, manipulate. So I'm going to train the model. I need a training data. I'm going to need a test data. So what usually people do is they take the existing data, this 100K, they divided that data into training data and testing data. Usually people go with 80-20%. So Sairam, I'm going to take this 100K, I'm going to divide into 80% to the trained data and 20% to the test data. When you do 80-20, please note, it won't come accurately, maybe a couple of rows this side, because it is going to get from the cluster. When it is bringing in the cluster, it will try to minimize the computation operation. It may not like to bring data in one cluster into another. I don't want to discuss some details about it, but just we are splitting it high level. Let's go. Okay. So I'm splitting it. I'm taking this ratings RGD, which is 100,000. It has a method, random split. It's a random split, not a first 80%. No, it's a random split. And the random split with 80%, 20%. It takes the input, it takes the random split method. Emma, it takes the array as input.
Yeah, this means like
So array of 0.8,
order,
80%
right?
means 0.8. Emma?
Random split means the data can be in any order, right? It can be of positive rating or negative rating, right?
That is correct. That is correct. So for 0.8, so it does a split. So the output will be an array. So let me run this so that you'll see. Okay. The splits object. The splits is doing what it is doing, Sairam. It is taking this RGD. This RGD is divided into 80% and 20%. So 80% training RGD, 20% testing RGD. That's why you see this variable splits. Splits is an array of 2 RGDs. It's an array. It's an array.
Why do we do that actually? Just to be on the, just for my
This is the only data we have. So you train, to create a model, you need a training data. Then
Correct.
based on the training, we get that model. Then we apply that model on the test data and compare the results. So what does it mean is, suppose the test data, I have a model. DK gave a rating for one movie as a 5. So how I make sure my model is accurate? So I apply a model on the DK and one product. I'll predict the rating. Then I will compare my prediction of that rating to what DK has actually given.
Okay.
Again, I repeat, DK has given for one product rating 4. But my model predicted as a 3. So the error is 1, 4 minus 3. So prediction ratings are this, the actual ratings are this. What is the average error? I can calculate. That's why I need a test data. Test data, Hari. Test data has the actual ratings.
Okay.
DK, our friends, has given.
Okay.
These are actual ratings. But I apply my model on the test data. I predict the ratings. My model predicted the ratings. So I will compare my predictions to the actuals. That's why the test data will be helpful. Do you get this, Hari? Maybe when we see it and we do it, you'll understand.
Yes, I think so.
Okay. DK, you got the point? So I split.
Yeah, got
Two
it.
splits. Two splits of this rating data. The first split is split 0. I'm caching it. Because machine learning does the iteration. I need it in memory. Split 0. So the companies need to have a memory in their cluster. Memory is cheap. Don't worry about memory. My first laptop I purchased in Singapore, it has a 1 gig RAM. Now I'm working with 16 gig RAM. I think you all know. So this is my SiRAM. This is my first split, which is like I'm calling it as a training. It's a ratings RDD, but it is a training rating RDD. My next split is second split. I cached it. The test rating RDD. I'll count this. I'm counting this. I'll count this. Don't worry about this. I'll talk about this. Let me do that. It is close. Almost 80,000. 79,814. It's the 20,000. 8020. The same number. I counted here also. These are redundant statements. Okay. Don't worry about this. Harun will talk about it. This is a string interpolation. Where if you put in Scala S, you can write any string. In between, you can pass the variables. These are the variables, val. You can pass it without plus string concatenation. Scala gives some syntax sugar. It's okay.
So, but we don't have to worry about the mechanism it followed to pick up those 79,814 rows. On what basis they picked up the 79, on what basis they picked up 20,000?
Random,
That
right?
is, as long as it's random, it's good. Because
Okay.
our idea is just to create model and to see it, right? Test it, right?
Okay, so okay.
What that model does, I will tell you. Okay. First is it's a data, right? Randomly, I took this the data, use this for training, use this for testing. Training is to create model. Testing to validate how good is your model, right?
Okay.
Okay. Now come, I have a training data. I'm going to create model now. Our training data, I'm going to create a model. It uses alternative least square modeling. I'll tell what it does in a high level at least. So, but let's see the syntax. DK, it uses new ALS. In the k-means, we use new k-means, alternate least square. I have ALS object. It has two hyperparameters. One is rank. It uses a matrix related aspect. It uses a rank. I'll tell what it is. It uses how many iterations you want to do, how much convergence you want to bring. Those can be changed based on the errors we'll talk about when we are doing hyperparameter screening. I'll make you understand what these are. But first, just see. It has two hyperparameters, DK. So I said that ALS, to create this model, I need to run on the training set, training RGB. That creates a model. Not details, but see high level. That makes sense, right, Sairam? High level? I have a model, ALS model. It has hyperparameters. And I'm running the model against the run against the training set. I get the model running. Okay. What we got, Sairam? Can you see this and see what is coming programmatically before I give you some idea on math behind it? Syntactically, programmatically, can you explain what this did?
ALS is the model, but what did it do? ALS.
So don't break your head. If I say you're Sairam, did anyone ask what is Sairam? Why he has this name? No, right? Sairam is your name. ALS is a model. This is how it is a recommendation model. It uses.
No,
that is the
I
package.
see.
Yeah.
No, I see the other model as well in that results. So I'm trying to understand the matrix factorization model as well here in the second line.
No, ALS is an object. Using
No,
ALS
after you ran that cell,
this
you have
ALS
two lines,
object
right?
is a model. This is the model.
Oh.
This is the
ALS is
ALS state model.
ALS is object and
Okay,
okay.
K-means is an object.
Yeah.
K-means
K-means
is
is
an
model, right? Oh, this
K-means
okay.
is an object. K-means model is a model object.
Oh.
DK, can you explain this to the team?
Yeah,
Syntactically,
basically,
what it is doing. Internally, don't go. Just any programmatic readability. What we are doing here.
yeah, you're doing new ALS, alternative least square algorithm that recommendation engine uses, right? And getting a ALS object. I'm not sure what that set rank and set iteration is doing.
Some hyperparameters.
Hyperparameters, and then you're creating a ALS model basically with the training RDD data.
Okay, we're creating a model using ALS object.
ALS object.
Running it. That
using
model,
training data.
That model is a matrix factorization model.
Srini?
What is this? I'll explain to you.
Maybe before going there, can you tell me or can you tell us what is the idea behind the ALS model? How it is?
Hari, you need to understand this. We need to progress very well. I said I'll explain all those mathematics later. First, syntactically, program perspective. What does it mean? I want everyone to be in the same page. Then we'll move forward.
Okay.
Srini,
Okay.
what's a hyperparameter? Because I'm not sure I heard this term before.
Oh, really?
Yeah.
Okay. Can anyone explain this? Hema, have you heard this before? Oh. Okay. Anyway, answer to your question, Kiran. See, we have this process. You see here, improve. In the case of K means how many clusters we have is a decision that helps you to improve the machine learning model. Is that correct, Kiran?
Mm-hmm. Yes.
So those parameters are called hyperparameters. Those parameters, K is hyperparameters there. Here in this model, rank is a hyperparameter. Iterations is a hyperparameter. Hyperparameters means some parameters that would affect your model efficiency apart from your training data. Training data is fixed, right? At least for now.
Okay.
So these are the parameters. Say this is 10. What it is, Hari, I will explain to you. First, I want to make sure syntactically we understand this. Okay.
I think, Srini, you need to mute some people. Sorry.
No, I'll do that. First, let's not deviate from the discussion, guys, everyone.
Sorry, there was a lot of typing sound. Sorry.
Okay, everyone is on mute. Kiran, please, let me finish Kiran's clarification. Kiran, is that clear, Kiran? That's important question. Good question you asked. Hyperparameter means any parameters that are affecting the model other than the data are hyperparameters. Is it okay, Kiran?
Well, okay, just now you mentioned that it's used when we are doing the iteration because we are trying to improve the model. So then we are applying that parameters on the data, right?
No, Kiran. You have data.
Mm-hmm.
You're running. You're training. To create this model. To create a model, you need to run against this data. That is correct. But to run, this is the driver. This is the driver. Like a Kiran is driving, Srini is driving. I was driving. You said, Srini, you are feeling sleepy. I think your driving habits are not good. From New Jersey to DC, let me sit on the driving seat. So you adjust your belt. And you adjusted the whatever it is, the speed. You had a gas, then started running the car. So how much gas you have in the car, how much speed you are running, those are parameters for the driver and the car. So that is ALS. ALS is an object, and that ALS object has a certain parameter, rank, certain parameter iterations. Those are parameters you are setting to the ALS object. Then that ALS object is the driver. That driver is running against this data to create a model. So this is fixed when we are doing at that time. But these are affecting whether Kiran is driving or Srini is driving. Depending upon that, we'll get tickets, traffic tickets. If I'm sleeping, the police may give some ticket. Driving.
Yeah.
You're driving good, you know the roads.
Srini, it is like, see, the number of iterations, it's not actually changing anything in the data or impacting anything in the data. It's only it always runs on the same data, but it only determines how many times that algorithm has to run internally, that number of iterations, but the data will always be the same, right?
That is correct.
Yeah.
Kiran, are we on the same page?
Yes. Yes, Srini, I understood now. Thanks, Arun.
No, that's good. So, Arun and everyone is correct. This is a for that object parameter. So what it is internally, we'll discuss after this. Just wait a couple of minutes. So, Hari, again, a question to you.
Yeah.
So I do that very well, as I told you. As Arjuna, you have to see the eye first. Then you have to figure out everything. You get this point first as a syntactically what it is happening here, programmatically.
Yes, I'm trying to. I mean, not 100% there, but yeah.
No, don't think it. This is the problem. If you think too complicated, it is a problem to you. There is no complication here to understand this. This is what is this? This is a val from a Scala syntax. This is a variable. New object is this is the ALS object that is created from that library. Is this sentence any confusion to you?
No.
That's all I want. That's all I want.
Yeah.
Hold on. That's all I want. And ALS uses certain parameter. You don't know about it, but this ALS dot set rank. It's a method. The way you're setting this parameter. This is you're setting for that ALS object.
Yeah.
This is set method. So your ALS object is ready, right?
Yeah. Because why I said not 100%.
Using this AL object, you are running against this.
Understood that, but only thing why I didn't set 100% is because of one, the set iterations itself, I didn't understand why we are running number of times, because you say
I didn't tell you that. Hari, I didn't tell you that. I said we'll discuss this. Hold a minute.
Okay.
I haven't talked about it.
Okay.
You don't know why it is 10. Put 10, put 11. Go and see error. When you need to see.
Yeah.
Earlier we put, you remember K4 we put. Later we change it to 10, right?
Yeah. I think we'll be clear as you proceed, Srini. So we can continue.
Okay. No problem. So guys, I appreciate questions, but don't make it too complicated. Okay.
Yeah.
So these are the parameters you set. You want to put 1, put 1. It doesn't matter. You are understanding. You are building a machine learning algorithm. You run it and see, then improve it. This is what the process is all about. Get data, clean it, train data, train it, test it and see, then improve it. What does it mean? That is what even iteration is all about. Somewhere you start. Even you remember, GK, we discussed about this K-means. Randomly 4 clusters. Even algorithm does that. Randomly it puts a point. Then it makes the cluster. Then it moves the point. This is called a trial and error way. Okay. Good. So it created a model. So this model gives you, if you apply this model, HEMA, on any user or any product, it gives you the rating. How it calculates, what is the math behind, we'll see. So in the beginning itself, when I started, DK, you remember, I came up with the problem, or our technical problem is, we have user, we have items, we have some ratings, we have a lot of missing ratings. Our machine learning model is going to find out all the missing. That is the problem we are trying to solve.
Correct.
That is what I started with the premise. DK, is that correct? At least our aim, what we are trying to do. How we do it, we'll discuss. But what is that? Aim. And it's a recommendation.
Right.
Sairam, is that correct?
Yes, it is.
Okay. Again, guys, I don't want everyone to say this is correct. So what we started is we have a user, we have an item, we have some rating. There are a lot of ratings. So our model is going to predict all these ratings. How it does that, we will figure it out. But that is what it's going to do. Then once we have Harish, tell me if all these missing blanks are filled, don't you think you know how to recommend to the user? If you filled all the things, out of these, what are the top 5? Don't you think for a user, when Harish logs in, your system can recommend top 5?
Yeah.
Harish, this is you. When you start, it shows only 1. These are blank. If a model can fill all this with ratings 4 or 5 or 1, suppose this is 1. Do you recommend this as the top 5? You recommend top 5 means 5, 4, whatever it is, right? Top 5. Is that correct?
Correct. Yeah.
If you have a rating, then you recommend top 5. Okay. So let me go to that point. What it is doing. So everyone, please focus. Just a little bit, bear with me. We're going to some mathematics. It's very simple mathematics, but only thing is long back you've done it. So you can recall. See, this is alternative least squares or matrix. What is the model? Sairam didn't like this, but he's going to like this. Sairam, can you read this? What is it?
Matrix factorization model.
Matrix factorization model. The mathematics behind that is, this is a user item rating matrix. A sparse matrix. Take a simple one. It's a 1 row, 2 rows, 3 rows, 4 rows. Here it is a 4 by 4. It need not be. It is a M by N matrix. Let me write it here. Give me 1 second. Okay. M by N. A M by N matrix can be written as product anyone can explain this to our team from your very earlier class? Kiran, Harish, Hema, DK, Sairam.
It is nothing but M by K into K by N.
Can someone please? Harish, DK, Sairam. Kiran, can you explain this? An M by N matrix can be written as two matrices. M by K matrix, multiplication, K by N matrix.
Yeah, when you multiply these two matrices, you will again get a m by n matrix. The two dimensions k and k will go away. So the first and the last will become the dimension of the matrix.
Yeah, everyone, hurry. Can you recall this? Or can you?
So M is the user and N is the product.
Yeah.
No, it's not that product. It's just multiplication of two matrices with dimensions m by k and k by n, which means that if it is 2 by 3 and 3 by 4, the result will be 2 by 4 matrix.
A 10 user, 20 product, 20 movies matrix is nothing but a 10 user,
5 product multiplied by 5 user and 20
multiplied by
5 users and 20 products.
10 user 5, then 5 into
20.
That's don't relate to products or this one. Just a matrix, mathematical display.
Okay.
Here it is, you can see this is user, this is product. Which is this? 4 rows, so 1 row, 2 rows, 3 rows, 4 rows, 4 columns. This is a 4 by 4. 4 by 4 is, so let's write this. This is 4 by 4. Four by 4. Let me write this. Is equal to. Sairam, tell me this. One, 2, 3, 4.
4 by 2.
4 by 2. How about this?
4 by 2, yeah.
That's 2 by 4.
This is 2 rows.
2 by 4.
2 by 4. 4 by 4 is 2 by.
No, 4 by 2.
4 by 2.
4 by 2
multiplied by.
Let me
2 by
multiplied
4.
by
2 by
2 by
4. 4.
So these 2 will be cancelled. These 2 will be cancelled. Look, I don't want to scare you, but anyway, come here. Come on. So a matrix in mathematics, so the package uses, you don't have to break your head, but just to give a sense of what is ALS, what is matrix multiplication model it uses. So a sparse matrix can be written like this. So this issue now from the user's perspective, some numbers. These are exactly ratings. These are some implicit numbers, implicit ratings. You can think it as implicit ratings. So these are users, 4 users, 2 columns. And here there are 4 products, 2 columns, some implicit ratings. So
why 2 columns?
Rows,
why 2 columns and 2 rows only?
It can be 2 or it can be 3 also. It doesn't matter. They will be cancelled, as I told you. You are right, DK. That's a good question. But start with just understanding. It can be. Oh, sorry. That's a good question. Where is it? Sorry for that. The DK has asked, hey, we have a 100 product, 100 by 200 product. You know, it can be 100 by, I said just 2. DK said why 2? Yeah, it can be, that is where K. That is where the K, rank. Here, that rank. This is the rank. Okay. Got it?
Yeah, yeah.
Rank. So that's mathematically it is correct. So what happens in the computation, that will be there. That will have impact. But mathematically it is correct. 100 by K product. Your 200 products. No, sorry. Your again rank. Rank. What else? Shall I say K for now? DK? So that people make sense to the people.
Yeah.
You asked a good question. Why 2 only? Right. It can be 2, it can be 3, it can be 10. So let's keep it as a parameter. But mathematically, it is correct. K. It is very, very simple, Sarah. Since I just said matrix and mathematics, some people are quiet. That's only that. So let me take you slowly into it. That's why I don't talk all these things when we start the program. If you mix everything, it's going to be very challenging. So especially if you teach machine learning next time, make sure you do like this so that people come to your class. Otherwise, people will be scared. Okay. So a M by N matrix can be written as M by K product K by 20. This is what exactly. So see, these are the numbers. These are some implicit numbers. You don't know. Some random numbers. But how those what happens? You put that random number. As far as the rank, that is correct. DK, you agree with me? This is 4 by 4. This can be 4 by 2. This is 2 by 4. 2 get cancelled. The matrices property is not violated. Do you agree with me as far as the rank at least concerned? Okay? You're on mute. Hari. Hema. Okay, let me roll back a little bit. Okay, Hema, I'm asking you a question. You unmute a couple of people. I need to ask a question. Otherwise, total silence is a little bit dangerous. Nagesh, in a matrix can be written like this mathematically. That is the rule of mathematics. If you have 100 by 20, that can be written as 100 by anything, product, anything multiplied by this 200.
Yep.
If you can't recall, please accept now.
Yeah. I remember that.
You remember that? Emma,
yeah.
If you don't remember it, please remember now. Everyone, I want everyone's participation. Sairam.
It is correct. Yes.
Yeah, I got it.
Okay. So the rank wise, this is good. So that is called the rank. This is it can be 2 or it can be 3. Only thing is, if it is 3, the third column will be here. The third row will be here. So they start with 2. Now go to the next aspect. Okay. What is the multiplication? Now see here how they multiply. DK, can you educate us how they multiply in matrix? This row multiply with column. 1.4, 1.4, 0.9 multiply with 0.8. Emma. I need someone to discuss.
Yes.
And move forward. Either Hari or Siva.
Yes, Srini.
Siva, tell me what is happening, how they multiply.
So
how matrices, I know.
1.4 is multiplied with
the column.
Yeah, right.
1.4 multiplied with 1.4.
0.9 multiplied with
0.8. The sum
of those two. Yeah.
So this is equal to that sum.
Yeah.
Okay. Now let's start this with here, B. Nagesh, tell me how you get this 4. Second row. See, this is, if you take this, multiply this, you get this. If you take this, multiply this, you get this. You take this, multiply this, take one row, multiply all columns.
Right.
This row, multiply this, you get this. To get 4, take this row, multiply this. Shiva, can you tell me the number? 1.4, 1.3 plus 0.9, 1.1.
1 second. Plus
Emma,
Srini,
what is this number? Emma,
that's
this is 3, right?
multiplied by 1.2 plus 0.9 multiplied by 0.8.
So it means this multiplied this is this, right?
Yeah.
Okay. How about this? Second row. We start with second row. This is second row, first column.
Yeah.
This multiplication, this, right?
Yep.
How about this?
Second
This
row
multiplication, third, right?
third column.
Okay. Now question to Hari. Hari, tell me how you get 5. How you should get 5.
Sorry, Srini, my internet just reconnected back. I got a question immediately. So,
Oh
just
man,
5 minutes I was-
you have a good excuse, man.
Sorry about that.
Just kidding. You're just kidding. See, Kiran.
I was talking
I
on
don't know why
mute. So it will be 1.5 into 1.3 plus 0.9 into 1.1.
Okay, this 5 is third row, right? So I'll start with third row. Second column, right? Third row, second column. So you are taking this and multiplying this, right?
Correct.
Kiran?
Yes.
Okay, let's start with 1. Siva, tell me, what is this? This is 5. What is the value when you multiply this? 1.5 and this one. 1.5 multiplication 1.3, 0.9, 1.1. How much?
0.9. So it is almost 1.95 plus 0.99.
Come on, don't ask me. Give me the answer. 1.5 into 1.3 plus 0.9 into 1.9, 1.1.
2.94.
Okay, 2.94. Whereas it's 5. So there is a difference, right? There is an error. Correct, Siva?
Yes, Srini.
Similarly, for this, there will be some error. Similarly, for this, there will be an error. Similarly, for this, there will be an error. So, what will, if you can adjust this properly, don't you think you can come close to them?
Yes, Srini. Yeah.
Okay. Anyone? DK, you there? Sairam, you there?
Yeah.
Sairam, please see. Just listen 5 minutes, everyone. Please observe. These are fixed. These ratings are fixed. These are the numbers that can be changed by the model. What this model is going to do is, it puts some random number. So then it checks with this. There will be a difference. There will be an error. So it will try to minimize the error. It will try to minimize the error. So then how it does this, DK, please observe. First, it starts with this. It multiplies, it finds the error. Then it changes these values first. Then again it computes. This is the error. Then it changes these values next. Then again it computes. It checks the error, try to minimize it. Next time, this is fixed. This will be changed. Again, minimize the error. Next, this is fixed. This is changed. So alternatively, it is changes. That's why it is alternative. Change this. Check. Next change this. Check. Next change this. Next change this. Next change this. Next change this. So like that, it does the iteration. Iteration 1, iteration 2, alternatively. In the process, it minimizes the errors based on this and this, what you got. As it minimizes, it converges to some value mathematically. 5 iterations. Sometimes, even you give 20 iterations, it might converge, it may not make it. What is convergence means? It may not make it minimum anymore. You remember when we did a k-means, it went to elbow. It is no more changing. So finally, at the end of the model run, what is the result, DK? You got some values of this, some values that you cannot change anymore. You get some best values of this, best values of this, which are as minimum as possible, mapping to these known values. Yes or no? I repeat.
Yes.
Yes.
You have some numbers which are as much close. Again, please understand, as much close. It can do what it can do, what it could do. Don't you think? Yeah, as much as possible, as little error as possible for the known ratings. Based on the known ratings, it got some values of all the cells here, some values of all the cells here. Hari, Kiran, Hema, everyone.
Yeah. If I have to give my understanding, see, for example, if you take a product C, if the average rating is say 1 or 1.2, whatever. So when we calculate over each iteration, then we are trying to arrive at a rating for that product C, which we can recommend to 10.
No, don't go. You are thinking quite ahead, Hari.
Okay.
You can think that first mathematically. Now we are talking mathematically. When I didn't talk mathematically, some people asked me to talk mathematics. When I talk mathematics, they are not talking mathematics. They are talking business.
Okay.
That is a problem in the learning.
Sorry,
we need to bring everyone into the same page.
No problem.
Some people even never heard matrices. So come on, guys, please. It's hard first time listening, but after that it's very easy. Now you all agree with me. These all numbers are filled. These all numbers are filled by some possible values that closely reflect these known ratings. Sairam, yes or no? DK, yes or no? Emma, yes or no?
That's correct.
Or you don't know?
Yes.
Harish?
Yes.
I agree.
Yes, Srini.
Very good. Now move forward. So this is a sparse matrix. It can be written as a matrix factorization. The alternative least squares, the algorithm. Every time it calculated checks, etc., it minimize the error for the known rating. So all these are known for that training. If all these are known, DK. Now question to you. Now let us find unknown. See, tell me what this value should be. This is the third row, third column. You will now use this.
Okay,
This
I
one, right?
use 1.5
Third row.
into 1.5 into
Third row,
0.9.
third row, third column, right? Third row, third column, right?
Yes, yes, yes.
So what will be this?
1.5
Again, question two. 1.5 into 0.9
0.9
plus 0.9
plus
into
0.9
0.2.
into 2.
Yes. So how about this? Tell me, how about this?
Okay,
This is
that
fourth
is
column.
1.2
Fourth row.
1.2 into 1.2 plus 0.8 into 0.8.
Come on, that is the catch. Now you see, you know the unknown values. So with the best possible values, again possible, best possible values with the known rating, we could come mathematically unknown cells, unknown rating. So that is what alternative least square. ALS, what it does is it takes this sparse matrix, make it into matrix factorization, two factors of the two matrix with a rank K. With a rank K, either 2, 3, 4, 5, you can adjust that later by seeing the error. Okay. So first fix some K. This is what the code. Fix some K. Set rank 10 or 20, whatever it is, 20 or 25. Fix some for now. Then these are number of iterations, 10, 15. Fix some values. Fix some values. So it affects only the computation. It doesn't hurt you. It will come to an iteration. Convergence. So what it does is, based on the known values, it found optimum values of these numbers. When these numbers are known, these unknown cells will be filled. Unknown cells will be filled. That is what exactly alternative least squares concept means. This is matrix factorization. Using this ALS concept, using matrix factorization, we got, come here, we have a model. We have a ALS model which does that minimization error. Using the concept of matrix factorization, it has a set rank. DK has a Y2. Yes, that is the rank. It can be 2 or 3 or 4. We start with 10 or 20. Later, you can improve. First, you start with some 10 or 20, 15. Okay. So you uses hyperparameters. Then that model is built running against training RDD. You get a model. You get a model. This model has the beauty. This model has, with that model, if for that model, if you pass any user, any product, LIS and A, LIS and B, you get some approximate rating score. Then if the model is good or not, we can check. Suppose C, LIS and C has a 4. It should be 4, actually is 4, but prediction may be 3. Then the error is 1 rating. Now you understood, Hari, Sairam, why you need test data? In the test data we didn't use for training. In the test data, let me come here. Use training for the model. Now apply this model on the test data. What is the test data? Test data has a user product rating. So give user a product of known rating, predict the rating using the model.
Yes, Srini. So that is why I had a question there. That's why I had a question there when we had an 80-20 on the training and the test data. Why
exactly. Now you connect the dots back. You're right. Okay, guys. Let's move forward. oh man, lot of time. In fact, I want to give Harun at 10 o'clock. Harun always says this to me. You tell one thing, Srini, and you do something. Okay. Harun, I can't help. Sorry. You know that. You know how big trouble I am.
That's
Teaching
okay.
this, right? Okay. Start here. Let me go quickly. DK Sairam, the dots are coming back, right? Of course, it takes some time to revise, etc. But the dots are coming right slowly.
Yes.
Agree?
Yes, sir.
Okay. Now look here. Now look here. See, let me take this guy. See, 196. I have 196. This is user ID. And this product 242 has a rating. So for that user, I'm going to apply this model for that user. See here. I'm taking a user. For that user, how many ratings should be there? How many ratings? For that user, whatever the total number of products, that many ratings should be there. So what I'm going to do is, I'm going to take top 10 ratings for that user. Let me say N is equal to 10. DK, what I'm doing here, for this user, I want top 10.
Top 10 recommended products.
Top N recommendations. I use that model. That model can recommend product. It has a method recommend product, which takes the user, which takes the number of recommendations you have. I'm going to print that. Let me run that. Top N rows. Look here. We get a rating object out. The model.recommend product is a rating object. That rating object has a user, the same user. This user, this product, let me see it, put it. I want 100.
Sorry, Srini, this top 10 or top 100 is like the sequel top 100, right? It's not the top as in the recommendation top, right?
This is here, based on the rating. 6.69, 6.34, 6.19, decreasing it.
Okay.
It is recommendation.
Okay. I was just trying to understand that. Okay.
It's a rating based on the rating.
Okay.
See here, products. So now quickly go. Now how we compare? Let's use test data. Test data. See, I have a test rating RDD. Don't worry about the syntax. Idea is, see, that rating object has a user product rating of test, Kiran. I will just take these two because this is the actual, right? This is the actual. Right now, I want to predict and compare for test. So I'll take user product. I'm pulling these two out. I'll talk about syntax later. I'm taking from Kiran. What I'm doing here, I'm taking a test data. Out of the test data has a user product rating. I will first pull this user product from it. Then I will predict. See, I will predict. I will use the model. I'll predict on the test user data. I'll predict the ratings. These are predicted ratings, Kiran, but the test data has the actual rating. I'll compare. I'll come to the syntax later. Let me come here. See what I'm doing here. You see. This is the prediction. I'm predicting. how I'm doing the prediction. Let me go here. This is predictions already. This is after predicting, I'm getting rating. This is actual rating. Then I'm comparing it. See, I'll come to the syntax because I need to go to an airport to pick my friend. But quickly, let me run. Then we'll work on that because there are a lot of things we discussed. How to test it, the syntax, I'll work on it later. But let me show you the idea. Idea is this. DK Hari. See, for test, there is a user ID, product, rating. Yes or no? Hari.
Yes, sir.
For test. Okay. Now, how about I predict using this? I'll predict. So let us say I have a user ID, product, predicted rating, actual rate. For user ID and for a product, predicted rating, I will use the model and find it. The actual rating, it is already there, right, Harun? Right, DK? Right, Sairam?
Yeah.
Yes, Srini.
Yes, sir.
Okay.
Yes.
Okay, let me jump into it. How I'm going to do. This is what I'm going to do here. Let me run a couple of programs, but I'll explain you later. Syntax. The time. Run. This is the comment I need to put. I have these are predictions. These are actuals and predictions. Okay. This is what is happening here. Please see here. Okay. Here. This is the user ID. This is the product. For that, what is the predicted? What is the actual? So don't you think the difference between these is error? Yes.
Correct.
We can find that a test rating and predicted rating. We can find the error and find its mean, then we can able to find its error. Then we can focus on improving it. So let me cut short a little bit. Let me cut short a little bit here. So we'll go back to that, but let's understand this. So we got the data, Sairam. We cleaned it. We created a rating object. We divide this into training test data. I trained the model. Okay. Then my idea is I will use on the test. When I use the model on the test, I get some predictions. But since the test data has the actual data, I'll compare the predictions with the actuals. Then figure out
does all of test data has actuals, or it's only some of the test data has actuals, or it doesn't matter?
Yeah, what is the answer, DK?
All are actuals because we took the test data from 20% from this thing. They are actual data only, right?
But that's a random, right?
No, randomly we picked 20%. Not the ratings. We didn't pick up random.
Yeah, all the data has ratings, out of which 80 we took as training and 20 we took as test.
Okay.
Yeah,
I understand.
Yeah.
That's a good explanation.
Random means out of those 100, which 80 go to training and which 20 go to test is just random.
Okay.
Yeah. That is correct. Exactly. So we imported the libraries. We got all the data. That data has we split it and we convert it into rating object. Then we just divide that into splits. We did a random split, but randomly rating object. We didn't we didn't shuffle the ratings. You're right, DK and Arun. Thanks for explaining. So then we are creating a model, ALS object. Set the rank. Rank is hyperparameter. Iterations, number of iterations is the computational iteration. We ran it on the test training data. We get a model. That model can do many things. Model is an object. Model is a matrix factorization model. How you got it? That came from a mathematical theory. Mathematical theory, which I'm pretty sure everyone got fairly good understanding. A lot of people feel very difficult, but I truly appreciate in such a short time, we all agreed to a common terminology. It's a mathematics, simple but powerful mathematics. A sparse matrix can be assumed as a two dense matrices. Those values, based on these, the library, the model has the ability to start with some random numbers, then start converging it. Put it, then verify it, change it. That is the idea. Alternative least squares means alternative least squares. First fix this, change this. Then fix this, change it. Fix this, change it. So that finally these values quite possibly represent these known ratings. Once you can't change anymore, once your library, your model can't change anymore, that is what you can do. That's what you say, you do your best. You do your best, then go to God. That's what people say in life also as a philosopher. You do your best, then take the help from God. So the model did its best. It can't improve anymore. With the given data, with that given K, with the iteration, okay, with that known, you got all predictions. But you want to gauge the error. That is where Hari, thanks to Hari, he agreed with us now why we need test data. Thank you, Hari.
Yeah.
Use the test data. The test data has actual. The test data has actual. Test data has actual.
Now I got it.
And for the model, for the test data user product, we got a predicted rating. This is predicted rating for user password of test data. This is the actual rating of test data. You can compare it. Next class we will see error. Then there is some metrics. Then we focus on how to improve it. There are sometimes you can't improve it. Then you apply it. Going forward, you start sending recommendations to people. Then you collect more data. And over a period of time, you have a wonderful system, a recommendation engine you have built. For that matter, you can build for any company. A learning system which improves this business. Awesome, guys. I think you did a great job. Harun, DK, any comment? How does it sound, at least, to start?
I think it's pretty good. You very well put it. I mean, so I think we understood, at least for the most part. Yeah, I mean,
we will work on it on a hyperparameter test. But at least now you see things are coming back, right? This process is helping us what we learned in chemistry. In K-means, we treated dense vectors, whereas this model requires a rating as input. Do you see that fine differences, TK? Right?
Yeah.
Hema, any comments? How does it sound, at least to start?
Great, Srini. Great. Like the topic is simplified very well. I think everyone got it.
Okay. Is it interesting where you can? Do you feel that you are having a weapon to build some solution to people, your companies?
Yes, yes.
Of course, there are a lot of data collection. You need to work with a lot of people. There are a lot of things, but at least the core. Okay, I know at least got it. Hey, Nagesh, any comment? We need to brush up. We need to revise a lot of things. But how does it sound? Kishore? Let me check with Leela, Surya Kam, and Harish.
Hi, Shini. So it was good, Shini. I like the model only, right? I had some doubts. I'll connect with you on it later.
No problem. Yeah, Harish, I agree. There will be some confusion. See, you might have to brush up your matrices. You might have to talk to some mathematics people, but that is all okay. At least we agreed on some points, I believe. Harish, what is your comment? You're on mute.
Yeah, Shani. So yeah, definitely now we are able to relate more how exactly the recommendations work. So we are able to connect with the real world use cases as well. Yeah, this is very helpful in a simplified manner.
No problem. Kiran, we definitely there will be some seminars on it. You know how I run my classes. You do some additional research. People come out with seminars, and of course I will be touching hyperparameters. But in a first stroke, how does it sound like?
It's very interesting, Srini, and actually I liked it better than big data, to be honest. Because big data was all about cleaning, scrubbing data, collecting from different sources. But here you're like playing with the data, you're doing something like really interesting, making something really interesting out of it.
You put a very interesting point, Kiran. It is applicable to everyone. It's a motivation for everyone. Because you are doing something with which you are providing a solution to a big problem of a company. You're not just doing a cleaning job. It's like, my wife asked me, at least help to cleaning the dishes. I do, but it's not very motivating, it's just a cleaning work. So anyway, I learned some cooking also. Now she's in India and I'm able to experiment.
Yeah, we remember your brinjal examples in big data. So I think I know that you've learned quite a bit of cooking because you did talk about your vegetables a lot.
Yeah, I don't have any luxury. I need to cook it. So Siva, you are participating good. I appreciate that. Siva Raja, I didn't hear anything from you.
Yes, Srini, this is very, very interesting. We are actually making, the model predictions. I think you just opened up a really, interesting path. Hope we'll have more and more,
Okay. Hey, Narayana, IIT Delhi, IIT Madras.
Hi, Srini.
What do you think?
I'm good. That sounds interesting, but there is little confusion about what is the hyperparameter. That is the repetition.
Confusion will go away. So
okay.
Confusion will go away as we spend more time.
Sure.
So
I'm right.
So everyone, I want to encourage. This is just the beginning. Just I'm giving a just first step. As you taste it, okay, then you will ponder it, we'll discuss, we will see, you will connect with dots as you read books or you read magazines, as you start hearing here and there. It's amazing, I tell you. It's amazing. You can just try build a career in just one of these skills. Please, I want you to appreciate how powerful is that. That is very important. So we'll discuss in one minute. Harun, I think we're doing. I want to hear comment from you. We will disperse our team. We'll connect tomorrow at 7:45. But first of all, what is your comment on this?
Yeah, Srini, I'm good. I think it is going as planned and in a good direction. So I guess the team is getting the hang of it, and
awesome.
As we progress, as we take out layer by layer, pretty soon it will all fall into place.
Awesome, guys. Very good comment, Arun. So if you see everyone, these syntaxes and all, you will get it. But you are seeing I'm just exposing the patterns to you. How these RDDs are changing, how the transformations are changing, how the actions are coming. So Harun is very well equipped to help us to be more comfortable. But we are starting with most difficult ideas and going to the writing syntaxes, etc. A lot of people love to write some syntaxes, come to here, but I trust me, they get exhausted. So this is based on a lot of thought. I'm designing the way we are moving. So we go to big picture, we go to problem solving, because when you have some problem in the hand, then a lot of things you can pour into it. Now we can worry about syntax. Now we can worry about alternative list scaling model. See how many things we are discussing. We are discussing how to split the array, how you pass it to a rating object. Hema quickly shown us how a rating object has a parameters. Our friend Sairamas is the product, user is fixed, it is fixed there. Kiran asked, what are the hyperparameters? All these things, and you guys are discussing this. And now, finally, we are talking about a solution. We are talking about a solution. Companies are recommending. Companies are doing it. Netflix, etc. So this algorithm was, everyone, this algorithm, collaborative filtering, alternative least square, this came from universities. Netflix conducted one competition, giving $1 million prize to improve their recommendations. Then some university team came and it shown they improved their recommendations by 10 to 20%. So that is when they won the Netflix prize. So they gave that $1 million to the research team. So that's how all the industry adopted this algorithm very much. Now it's very well applied everywhere. So we'll discuss a lot more. Any other last questions to me? Okay, then we will, tomorrow we'll start at 7:45. Harun is going to start.
Srini, one question.
Please.
So can we find some data sets for practice, just like what we are doing one of these? Do we have any sample data sets where we can?
Yes, actually, that's a good question. I'm going to post to you what I'm using. These are actually research. Even what I used is research-based data sets only. This is not simply to download movie lens. These are research projects, group lens, movie lens, group lens research have collected, made available rating data sets. So you have 20 million data sets also there. We'll go later. First we used 100,000. See here, this is a small set you can use, recommended for education and development. Then when we do it on the clouds, etc., Harun, we'll go to that 20 million or whatever it is.
Yeah, sure.
But that's a good question. But trust me, don't play with them now because it doesn't help you. Because your program, even if you have 1 billion rows, not even one line of code will change. So that's why we are starting with this. Then even we have a Last.fm music recommendation. Last.fm music recommendation. Recommendation. The last some libraries are there. I'll talk about. I'll share that. I don't want to overwhelm you lot with this. So by night I will post this data set from where you can recommend. Then I will share this particular code to you. So for now, it's late in India, and let's connect tomorrow at 7:45. Harun is going to take care, and I think I will also dial in. Everyone, have a good time.
Sure. Thanks.
Thanks.
Thank you.
Thank you, Srini.
Okay.
Thanks, Srini.
Bye, DK, Hari, Hema, Kiran, Kishore, Leela.
Bye, Srini.
Thank you.
Harish, Nagesh. Everyone, bye.
Thank you, Srini.